This is Chapter 1, Free Range Digital Design Foundation Modeling. And this is the first chapter with meaningful information in it regarding digital designs. What is digital design? My definition is digital design is the act of creating digital circuits to solve problems. So there's many ways to solve problems. Digital design happens to be one of those ways. What is creating a digital circuit? Essentially, that's creating a circuit that manipulates the circuit's inputs to provide the desired functionality on the circuit's outputs. This act of creating a digital circuit essentially creates a relationship between the circuit's inputs and outputs. Solving problems, once again, many ways to solve problems. We are going to solve problems using designing digital circuits, and certainly more on that later, the advantage of using digital circuits to solve problems. This is, as alluded to in the previous slide, this is your generic digital circuit. It's just describing it essentially as a box with inputs and outputs, so that as you can see, the inputs are on the left, and I know they're inputs because those arrows are pointing into the box. Outputs are on the right. I know they're outputs because, well, not only is it listed as outputs, but the arrows are leaving the box. So this is a typical circuit description. We'll actually modify this a little bit as we go along. This is digital design foundation modeling. It's a new approach to describing or learning digital circuits, learning digital design. I consider it a modern approach in that it's inherently a high-level approach. Being as a high-level approach, it depends on many types of circuit models. Models, topic for another chapter, but a model is simply a description of the two most important attributes of we'll say a modern approach to digital circuits is the fact that they're modular and hierarchical. Modular means they're comprised of modules that I plop down there, connect up, have all the modules talk to each other, and it's hierarchical. That means I can plop down all my modules, put it in a box, and make that into a module of itself and use that in designs. The hierarchicalness of it is essentially allows me to abstract the designs to a higher level. Once I do that, it aids in understanding the designs, and by all means it facilitates design of more complex digital circuits. So there are several attributes of digital design foundation modeling, and we've touched on a bunch of these before. A lot of these you may not understand first time you see this, and I plan on putting this in later slides so you can come back to it. These are the attributes of digital design foundation modeling. So digital design, it's using digital circuits to solve problems. Once again, we can solve problems many ways. This is using digital design. Digital circuits, they're best described using modularity and hierarchicalness and putting your design into a hierarchy, which means digital designs are comprised of a bunch of modules that exchange information with each other, generally speaking under the control of another entity, which we'll talk about in a little bit here. Digital design, or at least this digital design foundation modeling, I considered a structured approach to digital design, meaning that with just a few modules, basic digital modules, you can essentially design any digital circuit you want. Now, this is analogous to structured programming, where you can create any program you need using just a few basic structures. Or, put it this way, if you can decompose your computer program into these basic structures, it's going to be a well-structured program. Digital design, the structured modules that we're talking about are the foundation modules. We'll be talking about that in the entire book. We're describing these modules in terms of data, control, and status. The data in particular are the input data, the output data. The control signals are inherently input signals. Status signals are inherently output signals. We'll get into that later. Classify all these modules, all these foundation modules, as either controlled circuits or controller circuits. So the controller circuit is essentially controlling the controlled circuits. We're really interested in what's controlling our circuits. So typically I've broken this into 4 areas, which is no control. Essentially the outputs are based solely on the inputs. Internal control, external control, and circuit control. You'll see this in later examples, and we'll come back. 3 approaches to digital design. Brute force design is what we'll initially learn. It's extremely limited. This is what all digital design books used to do extensively, but we'll quickly get out of that. It's more of an introduction to Boolean modules and et cetera, et cetera. We'll get out of that fast. The next step is iterative modular design, which removes some of the limitations of brute force design, but it's also limited, and soon we'll get to modular design, which is the most powerful form of design that supports the modular design that we've been talking about. The top circuit here is essentially the old approach to digital circuits, where everything was just a box with an input and an output, blah blah blah. We don't want to do that anymore. We want to divide this a little bit differently, and what we're going to do is separate this into controlled circuits and controller circuits. So the controlled circuits have data inputs and data outputs, generally speaking, but they have control inputs. So these control inputs are controlling the operation of this circuit here. Status outputs here generally give indication that what's going on inside of this circuit. And generally speaking, what's going to happen is with this controller circuit, the controller circuit is going to read that status from the controlled circuit and kick out control signals. And those control signals are going to be used to control the controlled circuits. So once again, the old approach was I have circuit input and output. Now I have controlled circuits and controller circuits. Here's the old classification once again. It's just a big box with inputs and outputs, and now it's a little bit different. What we have here is a box with a bunch of little boxes on the inside. I know they're not boxes, but they're just modules all the same. Instead of just having inputs and outputs, I've divided those inputs into data inputs and control inputs. Instead of having outputs, I have data outputs and status outputs. Now inside this box, these modules all typically have data inputs, data outputs, control inputs, and status outputs, but I haven't listed them in there. So what this box is trying to show you is that this box in the middle here is actually controlling all the other boxes. I listed as a finite state machine or microcontroller. Of course, microcontroller, it's a computer that controls everything, blah blah blah, which means you can program it. FSM is finite state machine, which is pure hardware. You can get it to control things, but typically you don't program it with a programming language. So these are sequential and combinatorial circuits inside here. Those are the main types of circuits in digital design. There's also computer peripherals in here, which is maybe an IC, an integrated circuit that you bought off the shelf of some other type. So this is a nice little model here because it fits all of digital design. What's neat about this thing is it's really your first introduction to hierarchical modeling. So this top outside box is the higher level box. Inside this box I got these lower level modules which are doing something which is not really necessary to know for this design here, but once again these modules on the inside represent the lower level. This box on the outside represents higher level. I can take this outside box, plop that down in other designs.